We're going to talk about formal charge now. And formal charge is just a calculation we can do to try to figure out what is the best possible structure that a certain compound prefers. We'll use the word prefer. I want to jump from the top of the page down to the bottom and just talk about what kind of formal charges are preferred. So we're going to look at each atom in the molecule to decide which Lewis structure is preferred. And we're going to calculate that in just a minute. But I wanted to go over kind of what we're looking for the best structure. So again, it's just a possible structure. We're trying to use formal charge for the possible structure that's most likely. Okay. One of the main things we look at, if a structure has all formal charges of 0, that is the preferred structure. We're also looking to see, this is also kind of helpful, if the central atom has a 0, that might also be preferred. We're also looking if some of the smallest non-zero formal charges are present, that is a preferred structure. And if adjacent formal charges are 0 or opposite signs, that is also a preferred structure. It's also preferred if the negative formal charges are on the more electronegative atom in the compound. Again, the electronegativity trend increases across a period this way and up a group this way. Remember that fluorine is the most electronegative element on that periodic table. Also add this, and I think it says this up here somewhere, but let's add this, 5. If you have an ion, if you're drawing the Lewis structure for an ion, the formal charges must total the overall charges. Like if you have SO4 with a -2 charge, the formal charge of your oxygen, all your oxygens, plus the formal charge of your sulfur must add up to this -2. And I know we haven't calculated formal charge yet, so we're going to do that right now. Okay. All right. Remember when we were drawing Lewis structures that it's our goal for all atoms to have an octet. Okay. So in a perfect preferred Lewis structure, they would also have no formal charges, all formal charges of 0 if it's an overall neutral compound. Okay. Here's how you calculate formal charges. So the formal charge equals, and we're looking at a specific element. So the formal charge may be different depending on what's going on with each atom. Okay, so it's the number of valence electrons in the free atom. So you just get that off the periodic table, valence electrons, minus the lines, aka the bonds coming off of that element, and then minus the non-bonding electrons on that element, and those are our dots. Okay, this is a hard formula to remember, but you'll hear me keep saying formal charge equals valence minus lines minus dots. Okay, that's a little bit easier to remember. Valence minus lines minus dots. So let's look down here. This is not typically the way that formal charge is calculated. So you might see some halves. We're going to ignore those. Okay, we're going to come out with the same number, but we're going to ignore those. So let's concentrate on this oxygen right here. So oxygen, 6 valence, right off the periodic table. Minus lines. How many lines are coming off this oxygen? 1, 2. How many dots are on that oxygen? 1, 2, 3, 4. So this has a formal charge. This oxygen has a formal charge of 0. Okay. Let's look at the next one.